is a unit circle, which is a circle with a radius of 1 graphed on the UV axis. And what a unit circle does, it enables us to find the 6 trigonometric functions, which are sine, cosine, tangent, cosecant, secant, and cotangent. And the way that you graph things on the unit circle is you start with standard position, which is on the positive u-axis, and you would say theta, which is a term for angle measures on a unit circle, so let's say theta equals 30 degrees. You could say theta equals 30 degrees, so this, your terminal ray here, would be, your angle measure would be theta, which is 30 degrees, and this would be your terminal ray. Or you could have, let's say you wanted theta to equal 180 degrees. You could draw that like this, and then theta here would be 180 degrees. You can also have negative angle measures, so let's say you want theta to be negative 45 degrees. You would go in the, rather than the counterclockwise for positive from the u-axis, you would go clockwise from the u-axis for the negative, and you would have, let's say, theta here as a negative 45 degrees. As well as graphing negative and positive angles, you can also graph angles larger than the 360 degrees. So let's say you want to graph the angle of positive 720. You would start here, and you'd go, every time you pass the u-axis, it would be 360 degrees, so 360. And let's say you just wanted to go to 720, which would be right here. That would have theta would equal 720 degrees. If you wanted to graph a negative angle larger than 360 degrees, you would start again in standard position, this time going clockwise. So you would be negative 360, and then you would get to negative 720, and let's say you want your angle to be negative 900. And here, theta would be negative 900. Now let's say you graph the angle 30 degrees, which would be right about here. So this is where theta equals 30. And so you can then, from this position, if you're trying to find this coordinate, you can drop a perpendicular right here, and that will give you a triangle here, and this angle being 30, this angle being 90. So let's redraw that triangle. So it would look like this. You would have 30 degrees here, 90 degrees here, and then your 60 degrees here. And this is our old friend, the 30, 60, 90 triangle. And so we know the side lengths are now x, 2x, and x root 3. So from this, we know, as seen above, that we have this measure here, the radius of a circle, always going to be 1. So we know here that this measure is going to be 1, which means that this measure must be 1/2, and this measure must be root 3 over 2. So now we've got the coordinates for this new point, which we said were root 3 over 2 and 1/2. We can do the same thing again. This time we can use when theta is 45 degrees. So this would be our line here, theta being 45 degrees. Again, what we can do is drop a perpendicular, and now we have a nice triangle. And this is 90 degrees, and then that makes this, again, 45 degrees. So that gives us the triangle that has the measure 45, 45, and 90. And so we have a nice convenient 45, 45, 90, and we know that the ratio of the sides is x, x, and x root 2. Now with this information, what we can do is, again, we know that the radius here is always going to be 1, so we know that this measure right here is going to be 1. That means this right here is going to be root 2 over 2, and again on this side, root 2 over 2. So that means our new coordinates for up here are root 2 over 2 and root 2 over 2. Now we can do our triangle, which will look like this. We've got where theta equals 60 degrees, and so now theta equals 60 degrees. We can again drop a perpendicular, not a very good looking triangle, and have a 90-degree angle, making this 30. So let's redraw that down here. This looks very similar to our first triangle because, again, it is a 30, 60, 90 triangle. This time with the angle measures in different positions, but again we have x, 2x, and x root 3. So our coordinates are going to be a little bit different. This time this is going to be a 1 still, but this time this is going to be root 3 over 2, and this is going to be 1/2. So now our coordinates are a little different. We have the coordinates 1/2 and root 3 over 2. So now we've got our three triangles and our now three different coordinates. So we've got this coordinate, and this coordinate. And this is where we can apply our 6 trigonomic functions. And so our 6 trigonomic functions are sine, cosine, tangent, and then we also have secant, or cosecant, secant, and cotangent. So we know that sine theta is always going to be equal to whichever the y-coordinate is. So in this case, the y-coordinate is 1/2. So we know that sine theta is just going to be 1/2, and that cosine theta is always going to be equal to the x-coordinate, which in this case is root 3 over 2. So we write root 3 over 2. And tangent, which is going to be opposite over adjacent. So in this case, opposite, 1/2 over adjacent, which is root 3 over 2. So tangent will look like 1/2 over root 3 over 2, which you just cross these, and that equals 1 over root 3. Now, cosecant of theta, secant of theta, and cotangent of theta. These are all going to be a little bit easier than the previous ones because they all correspond to one of the 3 previous functions. So this one, cosecant, will correspond to sine, and so rather than being opposite over hypotenuse, it's just going to be hypotenuse over opposite, and same with the secant and the cotangent, so the fraction is just going to be flipped. So up here we can see that sine theta is 1/2, and that that must mean that this must be 2, because that inverted is just 2. Then secant would be 2 over root 3, and then cotangent would just be tangent flipped, so root 3 over 1. Now for each of these triangles, they are labeled, so this is R, the radius, for this triangle here. R, I'll do a different color. So R, and then you also have, since this is the v-axis here, this would be V, and u-axis here, this would be U. So for this triangle, there's R, a V, and U side, as there are for each of these triangles. And so for each one of the trigonomic functions, we can see that they're expressed in a ratio of these 3 letters. And so for sine, we can see that the ratio expressed here is V over R. For cosine, we can see that it is U over R. And for tangent, we can see, I'll have to write it small, V over U. Now for each of these, it's just the inverted version of the other one. So here would be R over V, and V over U, and then U over V. Now this is where we can apply these rules that we just created for these 6 trigonomic functions to more problems than just the 30, 60, 90 triangle and the 45, 45, 90 triangle.